Hello everyone. So in this video, let us discuss linked list, introduction and next of all, designing linked list, program from lead code platform. So first, let us see what is a linked list? Okay, so that is the definition of linked list here. Okay, actually in array, values are stored in contiguous memory locations, right? But in linked list, different memory location nodes connects together with the help of links. Okay, so that is a definition here. That is a linked list is a collection of nodes connects collection of nodes connects together collection of nodes connects together with yeah wait connection of links together collection of nodes connects together with links. Okay, fine. So here we have types of linked list, so called singly linked list. So next, doubly linked list. So next, circular, singly or doubler linked list. Okay, so we have totally three types of linked list. Okay, so I'll show you the structures of these linked list. Okay, so first of all, afterwards, I'll explain applications of this. Then afterwards, let us move on to the discussion of designing linked list. Okay, so first, all of you observe this. So singly linked list structure. Fine. Uh, So this is a singly linked list structure, guys. Okay. So here you are observing this values, right? Okay. So these we treat it as nodes. Okay. So each and every node you can observe some two parts here. Okay. So one is data part, another one is the next part. Okay. So N stands for next to here. Okay. Each and every time. So I won't type next to here. Okay. So with the help of that next pointer, so we'll make connection to the next node here. Okay. So I hope you understood. So it's collection of nodes connects together. So with the help of links, guys. Okay. And so the last node next connects to the none. Okay. So in remaining language C, Java, you can found null here in Python. So we are going to take none. Okay. And so this total for this total entire linked list, you are going to observe connection to the first node as head node. Okay, to the first node, so we have one connection so called head node. With the help of this one only, we perform the any operation here. It's very important. So this is structure of singly linked list. Okay, means here. So you can observe each and every node so having connection so only to the one node. Okay, but if you take the doubly linked list, okay, each and every node so having three partitions, okay. So have a look. This is a singly linked list. Next, so let us move on to the doubly linked list. So each and every node you are going to observe three partitions, okay. That is previous data part and next of also the next part, okay. So three parts you are going to observe in each and every node so in the doubly linked list. Okay. So let me draw the structure here. Okay, as usual to the first node. So we are going to have head address here. Okay, and next, so the next pointer so points to the next node in the linked list. Okay, previous. Let's take. So next here this 20 node previous is going to be connected to the so node 10, and next of all so 10 node previous is going to be connected to the so none, guys. Okay, n stands for so none, or else I'll type here full form, no problem. So next likewise, so 20 node next is going to be connected so to the node called so 30, and this is the previous and this is the next. Okay, so 30 node previous is going to be connected to this one, so previous node, and 30 node the next is going to be connected to the so none. Okay, and so to the last node, so we are going to take so the tail pointer here. Okay, with the help of this, we can perform insertions and deletions at the ending so quickly, guys. Okay, when compared to the so singly linked list. Okay, insertions and deletion operations so we can perform so quickly with the help of so taking tail pointer. Although if you take tail pointer to the so last node in the singly linked list, so we cannot perform so operations quickly. So just observe the structure now. First of all these you are going to observe the later. Okay. So each and every node contains so the three parts here. Okay. So here P stands for previous node. Okay. This is example for doubly linked list. Okay. This is the example structure. Okay, each and every node contains three parts: previous part, data part, and next of also the next part. So you are going to observe connections to the next node and so the previous node here. Okay, and so the next circular linked list means that one you can so design with either singly or else so the double. So let me take so with this one singly linked list. I'll show you here. Okay, so one next it is head, and next so two next, and so three next. So if the last node next so is connected so to the head node. Okay, so then we say that it is a circular linked list, guys. Okay, but suppose if it is doubly linked list. Okay, so we are going to make connections like this. Okay, so the last node next, so we'll connect to the first node here, and the first node so previous will make connect to the so last node. So this is doubly linked list. So doubly circular linked list structure, and this is the singly linked list. So in the circular form. Okay. So this is an example for example structure of so circular linked list here. Okay. So different types of linked list we use it for different purposes here. Okay. So actually singly linked list, so we use it for implementation of so the data structures. Okay, actually stacks, queues, trees, graphs, all these we can implement so with so arrays are next of all so the linked list. Okay, so here in the linked list which one we should prefer, so means for implementing so the remaining data structures means it's a singly linked list, because so just we need to perform so the operations there on implementing in the stack and next of all so queue tree or as graph. Okay, just we need to perform some other operations. There it's not required to have so the connections to the previous node. Okay, at that time so singly linked list is a better one, because so for doubly linked list you can observe it is taking one extra memory location here for each and every node. So with this actually you can observe the wastage of memory. Okay, so, but with doubly linked list, so we can design so applications like so I'll mention here. Okay, observe everyone. Singly linked list we use it for implementing so the remaining data structures. Okay, next doubly linked list. Okay, we use it for implementing so the real-time applications so called so media player. Okay, generally now you are observing so the values in each and every node, right? Okay, so in real time you are going to observe some song information, so image information, so in place of so the node. Okay, So media player and next of all, so the image here. If you so observe this, you know that you can move towards the forward direction and next of all, so the backward direction, right? Okay. So that is possible when we have so the connections to the next node and the previous node here. Okay. Media player image here are some applications of the doubly linked list here. Okay. And next, so for circular linked list. Okay. So let us take this. Okay. Round robin algorithm. So might be observed in operating system, so which we can implement with the help of so the circular linked list, guys. Okay, so likewise, so each and every type of linked list is so important here. Okay, different scenarios we go for using different thing. Okay, so if we don't know how many elements to be stored in the application, so then we go for using linked list. If we know already how many elements has to be stored, then we go for using arrays. Okay, you know this difference also, I think so, and some few differences were also there between arrays and linked list. So gone through that. There is important interview question also. Okay, so now. So I'll go for explaining so the single linked list so designing process here. Okay, so from the lead code platform, so all of you have a look at so that one. Okay, fine. Let us see the problem statement here. So program number is 707, which is from medium level from lead code platform. Okay. So let us see the problem statement. Okay. Design your implementation of the linked list. Okay. You can choose to use a singly or as doubly linked list. It's up to us. Actually, singly linked list is better. Okay. So afterwards, you try to design the same program with the doubly linked list. I'll tell you. So what changes you need to make here. Okay. Just you need to add one additional condition. So for this one, so that doubly linked list is going to be completed. Okay. So next, a node in a singly linked list should have so there are two attributes. Okay, so called value and next. Okay, so you observed right in the structure. So each and every node so should contain so value, data part, and next of also the next part. Okay, so here information is also given detail. Value is the value of current node. Okay, and so next is pointer or reference to the next node. Okay, actually, in C language, we implement so with the help of structures and pointers in combination. So, but here, so we have class and object. Okay. In remaining languages, we implement with class and object. Okay. So next, if you want to use the doubly linked list, okay, you will need one more attribute, so called previous. Okay. This one also you observed in the picture. Previous node in the linked list. Assume all nodes in the linked list are zero indexed. Okay. So remember this, just like in array. So here you should consider that all nodes are placing according to the zeroth index here. Okay. So next, let us see the implementation process now. First, so implement the my linked list class. Okay. So first, on creating so object for my linked list class, what has to be happened, ma? It has to initialize the my linked list object. Okay, and next of all, so the get method is given. Observe the coding screen here, everyone. What is given? My linked list class is given. Constructor is already provided. We need to initialize. Okay, what we need to initialize at the time of creating object for my linked list, I'll explain later. Okay. So next, what is the method we have? So get method, we need to return integer value. We got index here. Okay. So what we need to do, observe here. So get int of index, get the value of index the node in the linked list. Okay, if the index is invalid, we should return -1. Just like so in searching techniques, this is also search method only, right? Get is nothing but search. Okay, but here binary search is not possible because we don't have indexes. Okay, so here we are passing so the index. Okay, but based on so that don't think that so binary search is possible here with the help of linear search. We are going to return so the value present in that index. Okay, you are going to observe later. Next, so added head method. So to that value was passed. Okay, and so we need to just add to the linked list. It's not required to return anything. Okay, add a node value before the first element of the linked list after the insertion. The new node will be the first node of the linked list. So add tail method is given, value already passed. So append that so node with that value at the last element of the linked list. Add at index method given. So we need to add so particular so node at particular index. Okay. Uh, so the same information is given here, and for suppose if index is equivalent to the length of linked list, node will be appended at the end of linked list. Okay. If index is greater than the length, then only so node is not possible to insert it. These conditions you are going to observe in detail. Next, so delete at index method is given. We need to delete whatever the node which is present at particular index. So observe this first example, everyone. First, so my linked list, so object we need to create. It is not required to return anything. So first we need to add head. So we need to add head. First node we need to add at the beginning. It's not required to return anything. Next, at the tail position, we need to add at 3. Okay. So now we have a linked list called 1 and 3. It's not required to return anything. Observe input and output. So understood it. Afterwards, let us see how to implement it. Okay. Next, add at index. What is given in the first position? We need to insert the second node with value 2. Okay. Earlier we have so the linked list with 1 and 3. Now in between 1 and 3, 2 is going to be inserted. I hope you understood. So next, so get method called. So to the index 1. What is the present value present in the index 1 now? It's 2. So just now we inserted. So value 2 into the index 1. Okay. So the same value you need to return, and next of all another method is called delete at index. This methods is going to be called from the backend. Okay. So it's not required to call anything. Observe here. So the driver code is given. Linked list object creation. So get method, add at head, tail method, index, delete at index. All these are going to be called from the backend. Okay. So next, delete at index, so is called at index 1 again. Okay, what is present at index 1 now? So node with having value 2. It is going to be deleted and it's not required to return anything. Okay, and so again we have so the now in linked list only we have so the 1 and 3. We inserted value 2 in index 1. Okay, we retrieved that value which is present in index 1. We deleted value whatever present in index 1. Okay. Again, so we have 1 and 3 nodes now. Next of all, so the get method, we should access the node whatever present in the first position. So now we have 3. Okay, 3 values present. That one we need to return. I hope you understood input and output everything here in detail. Please do not use the built-in linked list library. Actually, you know this in Java language we have so linked list class. Okay, so what are the languages we have? So the inbuilt classes. Okay, we should not use that. We need to design whatever the programs are present in the backend of so these functions. Okay, so that is the thing required. Next, so first let us see one by one. Okay, before going to so think about object creation of so the my linked list. So designing part of constructor. So you need to observe one more thing here. Okay, this is the very first step you need to observe. So have a look. See, in each and every node, what you observed in single linked list. So the data part and next of all, so the next part, right? Okay. Each and every node you can observe. So the data part and next of all, so the next part. Okay. So what you need to do here is, if we found the same thing is repeating, so again and again in C language we take so the structure. Okay. So, but here in remaining languages, we have class and object system, right? Okay. So we go for defining, so node class. Okay. In that class, we are going to define, so the two attributes. Okay. One is data attribute. Data attribute is going to be initialized with different values. Okay. Different times. So we are going to pass different values and create so the nodes. Okay. And initially, and one more attribute so called next pointer. Initially, at the time of creating some node, okay, so we don't have any nodes towards the right side, okay, so that's why initially we are going to assign next pointer to the none, okay. So next pointer initially at the time of creating node will initialize to the none, okay. Afterwards, so in the linked list class, we are going to observe how to create nodes and how to make connections so in between them, okay. So I hope you understood. First, I'll define. So this that is the node class. Each and every class contains two parts: node part and next part. Okay. So different. So data I'm going to get at the time of creating. So the node I'm going to initialize. So the different node values. And initially, next pointer I'll take it to the none. Okay. Let me complete so this process. Before to the my linked list class. Okay. I am taking so the node class here. Okay. In node class, I'm defining so the constructor. Okay. So in this constructor, so this constructor I am defining so as accepting so data value. Okay. So the time of creating so the different nodes, we are going to pass different values, right? So I am going to collect so those values into the data variable. Okay. The time of creating so that particular node to that particular node data part we need to initialize that value. Okay, so that process I am completing here. Okay, so observe here, so self dot data is equals to data. So what this self points, guys? Okay, so this self so points to the current node address, right? Okay, current node address. So to the current node data part, so we are initializing. So whatever the value we are getting, so here, okay. So I hope you understood. And what I said next to this, we need to initialize. So the next part to the none. Okay, 1 minute. So fine. Listen. Okay, fine. So listen. So the next pointer. So initially we should assign to the so none at the time of so the creating node. Okay. So this is the node class part. Okay. Next. Now let us focus on the so my linked list class. Okay, at the time of creating so the my linked list so class object. Okay, so what we should so perform here, let us discuss now. Okay, so remember one thing. So here we need to work with the indexes. Here we need to retrieve value from the particular index. Okay, we should go for adding and deleting value at particular index here. Okay, so that's why I'm going to maintain so one variable called size. Okay, with the help of size variable, so I'll track. Okay, so how many nodes we are inserting into the linked list here. Okay, with that, so finding the length of linked list is also going to be completed. Okay, so now what is the next point? So we need to focus here. Observe everyone. Okay, So again, we are going to create, so whatever the structure you observed in the, so beginning, okay? So have a look here. At the time of creating, so to the entire linked list, so what you observed here, okay? So head address you observed, right? Okay. So at the time of creating, so linked list, initially, so head pointer, so we should take to the none. Initially, we don't have so the any nodes, okay? No nodes are created in the linked list. So what I am saying here is at the time of creating, so the linked list, so initially, so head pointer should point to the, so none, okay? So remember this. So let me complete this process and afterwards let us see one by one. Okay. What I said at the time of creating, so the linked list, so object, so this constructor invokes, right? Okay. So here in this constructor, so what you need to do, self dot, so initially head pointer, so we should, so make it point to the none, right? Okay. And next, uh, so what I said, we need to keep track on, so size variable, right? Okay, initially I am assigning so the size to the zero. Okay, so this is my linked list creation here. So each and every method, so I explain in detail. Okay, so one by one. So let us see now. Okay, first, this one completed, right? Okay. So now let us focus on this one. Okay. Added tail. Observe the structure. Okay. Sequence. How I'm so taking so the methods here. Okay. With the help of add tail method only. So we go for creating so the linked list structure here. Okay. So let me complete. So this one add tail method. Okay. So what we got, so value from the calling method, right? So by passing this value to the node class constructor, so first of all, we are going to create so the node, okay? This step is fixed, so for all addition methods, okay? Whether we need to insert at beginning or else at the ending or else in the middle, okay? We first of all, the first step is we should create so the node with whatever the value we got, okay? So let me complete so this method now. First of all, observe everyone. So let us take that first of all. So we got this call, okay, that is add of 10. So add at the tail, guys, okay, or else let us take it detail. Add at tail. So we got value 10. So what is the first step? So we need to perform. So with that value, with whatever the value we got, we need to create so the new node here, okay. So we are going to pass this value to the node class constructor. So and we'll create so the node, okay. So initially what happens in the node class constructor, we taken so the next pointer to the none, right? Okay. Next pointer points to the none. So for this node, we are going to take one reference called new node, okay. So initially, so we created, so to this variable, okay, we are going to assign an object creation process with value 10. So with whatever the value we got, okay. And this is the first step. For suppose, uh, here the first node creation process is different when compared to the remaining nodes, guys, because so for the first time creation, so we need to initialize so the head node to the so new node here, okay. Initially head node, so we should assign to the new node, okay, because initially so head is pointing to the none, right? Okay, so what you need to do here, initially head address, we should assign to the so this one, let us take initially, so head address we should make it as pointing to the, so the new node. This is the first step, okay. Now let us take so another call, okay. Again, so we are getting so call add at tail only, add at so tail. now we are getting, so with the value 20. Okay. So what is the very first step? So we should create a new node. So with the value whatever we got, right? Okay. So observe here with the value whatever so we got. So we should create initially what happens. So the next pointer so points to the none. Okay. So now this one is having so the new node reference. Okay. Earlier, so this one is the new node. Now this is the current new node, right? Okay. So I'm removing this address now every time so it changes. Okay. Now listen. So now we need to establish connection in between so the 10 and 20 here. Okay. We should not go for directly making connection of so the head address. Okay. Head next on making connection to the new node head next on making connection to the new node. Yes, you can make connection to this node here, 10 and 20. So, but what about for the next upcoming nodes? Okay, so that is not correct here. So, what is the procedure here for performing a connection? I'll explain now. Initially, so head address we should copy into the so temporary variable. This is the step we are going to observe. You are going to observe each and every so method. Okay, in each and every program of so linked list. So initially we'll take so the head address we'll collect into the temp and we check whether so that temp next is pointing to the none or not. Yes, it is pointing to the none. If it is pointing to the none, we stop traversing. Okay, we stop traversing and so we'll make connection with the help of this temp variable. Temp next, so we make connection to the new node, guys. Okay, temp next we make connection to the new node. Earlier it pointed to the none, right? So now it is going to point to the so 20. I hope you understood. With let us see with one more node. With this, you are going to clearly understood. Okay. So add at a tail. So last one, last method call. So this is the structure you observed in the beginning. So we are reconstructing so that. Okay. So what is the very first step? So with the value whatever we got, okay, from the calling method with that, so we should create so the new node here. Okay. 30 and initially so next points to the none, guys. Okay. So now this is the new node. Okay, this is the new node. So reference ma, and I'm removing so the new node reference here. Okay, let us remove this one also. So now we need to make so connection. We should establish connection in between so the 20 and 30 here. Okay. So do 20 having any reference here? See, remember one thing in linked list to perform any operation. So we require some so variable. Okay, we require some reference. Then only it's possible to make so connections here. Okay, so then what we need to do now? Initially we should take head address into the temp. Okay, and we should check whether temp next is pointing to none or not. No, it's not pointing to the none here. Okay, what we need to do if it is not pointing to none means we should update so temp to the next node. This procedure has to be repeated. Okay, so keep on. Now check whether temp next is pointing to none or not. Yes, it's pointing to none. Whenever it's pointing to none, what I said earlier, we should stop so traversing now. We should make connection in between. So the 20 and so the 30 node. Temp next, we should make connection to the new node. Okay. So that what happens? So earlier it is pointing to the none, right? Now it is going to point to the so the new node. Okay. So I hope you understood. Okay. So let me remove this one now. I hope you understood. So how we created this one now. Singly linked list structure. Singly linked list structure. So now we created. So by doing like this, okay. Now let us implement this part, okay. So let me complete this one. First of all, add a tail, guys, okay. So what I am saying here is, okay, the very first step is creating so the new node, okay. New node, 1 minute. See, new node I am creating. So here, okay. So how we can create? So the node, new node means. So here we have the node class constructor. Already we created it. Okay, we designed it. So with the help of node class constructor, so I am passing so value, whatever the value I got to this data. So that data is going to be initialized to that part of the node, and initially, so next is going to be point to the none. Okay. So observe here to the node class constructor. So I am passing a value here. Okay. I hope you understood this one. To the node class constructor, so we are passing the value. So that value initializes to the data part of that node, and initially next part is going to be assigned to the none. Okay, I hope you understood now. So now to that node we have so the new node reference. Okay, if we go for so creating next time is so next node is having the reference of new node. Okay, likewise each and every time so it differs. Next. What is the first step I said? Okay. Initial first node creation process, remaining nodes is different, right? Okay. Initially, so now head is pointing to the none, right? Okay. Observe here. Initially, we taken so the head to the none. If for suppose head is pointing to the none, simply what we should do here. So head address we should assign to the new node. This is very important here. Don't forget. So with the help of head only, so we go for performing so the any operation. Okay. If I suppose head is not pointing to the none, okay. If it is pointing to the some other node, okay? If it is already pointing to some node, what is meaning of that? It's not empty, right? If it is not empty, so what I said initially we should collect a head address into the so temp variable, right? Okay. Initially, we should collect head address into the temporary variable until temp next so is not none. Okay, temple next is none. We should keep on repeat the loop. Okay, so the condition I am taking here temp next if it is not is equals to none as we go for so processing. Okay, what we'll do simply we update temp to the temp next location here, guys. Okay, temp we go for updating to the temp next. So whenever temp next becomes so the none, it is going to stop. Okay. In that scenario, what we need to do? So this temp next connection we should make to the new node. Okay. So that one node and another node is going to be connected. Temp next is equals to so the new node here. Okay. And irrespective of this, if else, okay, we need to increment so the size by one. What I said initially, so we need to maintain so the size also, right, for checking boundary conditions, okay, and for getting count of nodes in the linked list, okay. We are using this. So what I am doing here, irrespective of if else, either if it is the first node or else so the any other node, okay, we need to increment so the size by one. On increase on adding some node into the linked list, we need to increment so the size by one here. Okay. So fine. This is the added tail. Now let us move on to the added head. Afterwards, let us move on to the added index, guys. Okay. Now let us see added head here. Okay. So let us take same picture. Let us remove these function calls. Let us take head. So again, let us take so the base condition. Each and every time we should first focus on the base condition, guys. Okay. If for suppose head is pointing to the none, okay. So simply what we should do, we should create a node and so initially it points to the none and you observe now new node. Okay, head address. First we should create a new node and next of all, so this head address we should assign to the new node. Okay, so this is the base condition. For suppose if linked list is having it, this one you already observed, right? Okay, so that's why I'll go with the next one. 1 minute. Yeah, fine. Now let us take so this. add at head. Let us take so node called 40. Okay. So initially head is not pointing to none. Some nodes are there in the linked list. Okay. So now we need to create a 40 node here only, right? Okay. So let us complete that process here. First of all, what is the very first step? It's fixed, guys. Okay. We should create so the new node. Okay. I'm creating some new node here. Okay. Initially new node, and initially so that new node next so is going to be pointed to the none. Okay. So this is the very first step. Okay. Next, after this, what is the set next step? Simple, right? Okay. So this new node, we need to establish connection in between. So this 40 and 10, right? Okay. So simply what we should do now. So this new node next, so we should make connection to the so head node here. Okay. New node next. So we should make so connection to the head because this current node is having new node reference, okay, and the first node is having head reference. With the help of this, we can make so the connection now, okay. So that what happens earlier it is pointing to the none, right? Okay, now it is going to point to the so 10 node, okay. And after making connection, so if you stop here itself, what happens? It is going to start traversing from the so first node here, okay? From so node one onwards, it starts traversing. So what you should do, we need to start traversing from the node 40, right? Then only so insertion of a node at beginning is going to be completed. So what you need to do, what is the next step? So the head address we should update to the currently created new node. Simply head address we should assign to the new node. So two steps we should follow, guys. That's it. Okay. First we should create the new node. Okay. New node next we should connect to the head node. Afterwards head address we should update to the new node. Okay. So already first step, creating so the new node. Only two steps you should so observe here. Connecting new node next to the head node, and after that, so updating head address to the so currently created so the new node. Okay. So let us complete this process here. Observe everyone. First, let us complete creating so the new node here. Okay. New node constructor. To that node constructor, I am passing value whatever I got here. Okay. Next. So what I said, if for suppose head is pointing to the none, okay. So new node address we should assign to the so let us take this one. Self dot head is equals to the new node, okay. If it is pointing to the none, it's not required to make any connection. Simply we should assign new node to the so head node here, okay. So if not, okay, so then in that scenario control moves to the else block, okay. What you need to do? Simply we should make so the connection. New node next we should make connect to the so head node here, okay. New node next we should connect to the head node. Afterwards head address we should update so to the new node here, okay. I hope you understood. Two steps. New node next, first of all, we are making connection to the previous head. And so the now after that, so head is we are updating to the currently created, so the new node, okay? That's it. Irrespective of if else, so once again, what you need to do, we should increment so the size by one here, okay? Because so we need to track so the size here, okay? For working with the base conditions, so the size is required. We are going to observe. Understood with the next method onwards, okay? We are having only one method, so here that is called add at index, okay? Once after completion of this, let us move on to the so deletion at so index and next of all saxing. Only three methods remaining, okay? So don't worry, just listen with patience. So let me complete add at index method now, okay? So have a look. First of all, so we should think about so the base cases here. Okay, Fine. So let us consider that. So we need to insert some node with value 40. So in between, so the 20 and 30 guys. Okay. So the very first step is common. So you all know this new node creation. Okay. Initially, so the next points to the none, right? Okay. So fine. So but here we need to focus on the base condition. So here, guys. Okay. For suppose let us take so this method calls. Okay. Add at index add at index minus 1 comma 40. Is it possible? No, right? Okay. Minus 2 40. So likewise negative indexes are not possible, right? So for this we need to take one base condition. Next, so the another thing is, so what are the indexes now? This is the 0th index, this is the first index, and this is the second index, right? Okay. So here it is possible to insert. If we go for inserting, so the new node, what happens? This is going to be inserted into the second position, and this one changes to the third position here. Okay. So or else, let us take so one more thing. So if for suppose we need to insert value index, okay, if we need to insert value 14 index 3 means I say it's possible. So this is present at index 2. This one we can insert at the last position, right? Okay. So, but is it possible? So observe everyone carefully. Is it possible to insert uh, node 40 in index 4? We don't have. So next to node 2, so we are going to get node 3. If we go for inserting this node, this one is going to get index 3. So if index is greater than of size, so observe here, what is the condition we need to use? Okay, carefully. What is the size now at present? So the size variable is holding so 3, right? Okay. If for suppose, so index is less than 0 or else index is greater than size, okay, then it's not possible to insert, guys. Okay, if although index is matching with the size, okay, if index is 3, so then yes, we can go for inserting in the last position. Okay, if index is greater than size, then it's not possible. Okay, I hope so you understood this. This is the base condition we need to take. Okay, so we are not going to perform any operation if this any one of these condition becomes true. Simply we return control back, okay, to the calling method. We do not perform any operation, okay. And so here, for suppose let us take index value as 0, okay. If we want to insert so this new node at the 0th index means it's nothing but inserting node at beginning, right? Okay, simply I'll make a call so to insert this node in the beginning position. Okay, again I won't write. So for index 0 I am not going to work, and next of all less than 0, if it is greater than size, not going to work. Okay, and if it is, if index lies so in between, then only I'll go for performing operation. Okay, I hope so you understood this. Let me remove this one. Now let us take so this one, guys. Okay, that is we need to insert value 14 index 2. That is my operation. Okay, I hope you understood. So now listen, we need to insert a new node. So with value 40, we need to insert at index 2. Well, the very first step is common. So now creating so the new node. After that, so we need to make a connection in order to insert this one at index 2. Okay, so this 20 node we should connect to the 40, and this 40 node we should connect to the 30, right? Okay, so for doing this, okay, we need some reference to this node here, but now we don't have so the any reference. Okay, so without any reference, we cannot do anything in the so linked list program, guys. Okay, so that's why what we need to do, we should get reference. Okay, for this node. Okay, we should traverse. We should get reference to here. Okay, For getting reference, what we need to do here is simply we should traverse. Okay. So traverse means, so observe here. Initially, I'll take so temporary head address I'm collecting into the temp, okay, and so I'll take count of nodes as one, okay, initially because I'm collecting head address into the temp, right, okay. So not I'm not taking index 0, guys, okay, remember. Next, so I'll check whether this count value is matching with the so position 2 or not, okay. No, it's not matching, right? Yes, I'll go for updating so temp to the next node, okay. On updating temp to the next node, what I'll do, I'll increment so the count by one. Okay. Now, so after updating, once again I'll check whether so the count and position are matching or not. If matches, I'll stop traversing here. So I'm going to get reference to the so the previous node, okay? So the previous node where we need to be inserted the new node here, okay? For getting reference to the previous node only, we started traversing from the count one here. We taken so the count one, okay? So we should not move to the 30 node. We should move up to 20 node only, right? Okay. That's why I started count from one. I got reference, okay? Now here you need to remember one more important point. Only again you are going to observe two steps. That's it, okay? But so observe those two steps carefully. For suppose if you make temp next, look here. If you make temp next connection to new node, okay. Let us take so this temp next connection. If you'll make so to the new node, okay. And afterwards, what you need to do? So we should make this one, right? Let us remove this. So now this 40 next, we should connect to the 30. Do this 30 having any reference here? No, there is no reference. So how we can make so the connection now? Okay, it's so completely not possible now. So on although if you make so one thing, okay, so some few members do like this, okay, the new node next, so they'll make it like this, okay, temp next is actually pointing to 30, right, okay. So on making new node next to the temp next, okay, they'll consider that so 40 next is going to be connected 30, but that is not going to be happen, okay. So few members take like this new node dot next on assigning so to the temp next means here right side what happens, so 20 next means it is going to take so 30, you feel this actually, but this is not going to happen because what happened is, so in the previous line temp next we connected to the so new node, right, so that is 40. So here what is going to be initialized, so 40. So means what is going to be happened, new node next is going to be connected to the so temp next, so that is, so it is going to be connected to this node only, okay. This is process is going to be happened. So now what we should do here, okay, for avoiding this I'll explain now, listen carefully, okay. This is the not first step we have to use here, okay. So the very first step, so we have to use here is first, so always remember this. We should finish the right side connections. Okay, then only we should go for so making so the left side connections. Okay, so that so easily you can make establish the connections here. Be careful while making so the connections here. See, observe the new node next. So we should connect to the 30. So 30 reference we will get with the help of temp next, right? Temp next means what? It's 30, right? So simply new node next on connecting to the temp next, what is going to be happened? It is going to be connected to the 30, right? So observe this step, everyone. So new node next on making so connection to the temp next. Okay. So what is going to be happen? So 40 next is going to be connected to the temp next. 20 next means right side what happens? So 30 it is going to take. Okay, right? So it is going to complete it now. So now what you need to do? So now we can finish this step. Okay, temp next. So on making connection to the new node. Okay, so this connection is going to be break. So this one moves to the index number 3 now. So this is the next step. Temp dot next on making so the connection so of the new node. So what is going to be happen? Simply 20 next is going so to the node number 40. Okay, 20 next connected to 40 and 40 next is connected to the 30 here. Okay, so fine. So let me complete this process here. Okay, so here just I'm uploading so there's half of the video here. Next remaining half of the video, that is delete at index and next of all get method I'll explain in the so next video. So actually it's already lengthiest one, that's why I'm dividing into the two parts here. Okay, so just addition operations I'm completing in this video here. Okay, so observe everyone. First, what we need to do, we should check the base conditions here. Okay, for suppose index is less than 0, or else index is if it is greater than of self dot size. Okay, we should return control back. Okay, next. For suppose if index is pointing to the 0. Okay, already we need to insert at the beginning, right? Okay, so make so to insert at the beginning here. Okay, self dot head dot value. Okay, if not, then first of all go for creating so the new node here. Okay, and next after that we need to traverse to the before node to where to be inserted. First of all head address we should copy into the temp. Okay, next so count initially will take to 1 up to where we need to traverse it denotes by this index here. Okay, so while count not is equals to so index. Okay, so whenever count becomes so the index, it is going to be stopped. Okay. So fine, temp. So I'll update to the next location, and so count I'll keep on update here. Okay. Count I'll update, and so whenever it moves to the index, count and index matches. Okay. So we'll stop it, and we need to make established connections. Okay. So what we need to do, new node next, we should make connection to the so temp next here, and so the temp next we should make connect to the so the new node here. Okay. So this is the first part, guys. I hope you understood. Okay. So let us discuss these two methods, delete at index and next of all get method. Okay, in the next video. So don't forget to watch the extension of that, and I'll type run and execute also this one. Okay. So that's it. Let us meet in the next video. So thank you everyone, guys. Okay.